here's another project I've been working on. So this looks like we've got a scroll bar here. You can see there's a bunch of different stuff in the middle of the window. When we run this, it looks like an array. We've got a whole bunch of different elements. There's something different about them. Some of them have controls mixed in on their front panels, and we can see that they move throughout the display appropriately. If we stop this and start this again, the color layout is completely different. So this is randomly picking which panels to put in each slot. And there I just gave it away. This is an object-oriented user interface demo. This would work great for MVC architectures, or just anytime you want to easily manage the display and execution of user interface panels. We're going to be focusing on this panel array manager right now. There is another manager that is just for windows that would be being displayed by themselves or embedded in like individual subpanels. But then I've also created this utility class here that is inside of a PPL that simulates an array view. So what this demo is doing is we've got these three different panels here, which are panel A, B, and C here in this library. These three classes inherit from PPL panel, which then inherits from panel. So if we look at this guy's class hierarchy, show class hierarchy, we see we've got the base panel, we've got our intermediate PPL panel class, and then we've got panel A, panel B, and panel C. If we look at those there, those are the different panels that we saw, and so their sizing doesn't matter, but we can see they've got different front panel colors just so they can easily be differentiated, and panel A has some extra stuff on it just because I was playing around with that. What this intermediate class here does is it provides a common capability of tracking an ID string that will then be available for anybody that inherits that class. So what we've got here is we have the three panel instances, the concrete instances. We're just putting them in an array, and then we're randomly choosing one of them to create. We're calling its constructor function. We're going to set its ID, which is just the number it is, the index it is, formatted into a string. Then we're going to use the base panel method that's available to get it actually running. So this is actually going to start this panel VI. So whatever panel VI the concrete instance, the concrete class implements, it'll actually get that running in the background. So even before it's visible and inserted into one of these subpanels, it is running in the background. And then we're going to go ahead and make sure all of them are added to our panel array manager. So the panel array manager is this guy down here. We are initializing it with just an array of the subpanels. So these are the 9 subpanels that correspond to the 9 subpanels that are available on this front panel. These have all been manually laid out. And then we also have a scroll bar, which is just the numeric scroll bar you would get. Let's see if I can get this moved somewhere. So it's just this numeric vertical scroll bar from the numeric palette. And I've laid that all out manually to make it look like it's an array that takes up the whole front panel. So we register with the panel array manager, and then we're doing this other trick that I've provided. So if you're familiar with deferring front panel updates, when you're trying to update a whole bunch of front panel controls or indicators at once, and you want to get rid of the flickering or the wave that you can see as updates, as VI server makes it to each of the updates in turn, we're going to tell this panel array manager that we're going to be changing a whole bunch of stuff at once, and we want these to all get added as quickly as possible. We don't want it to be reassessing where panels should fit, if it needs to put a panel into one, if it needs to put one of these panels into one of the subpanels. So we're going to tell it, hey, we're doing a whole bunch of stuff right now. Go ahead and defer your updates until we turn defer updates off. So we got our panel array manager created. We're going to add 100 of these randomly chosen panels into it, and then we're going to tell it, okay, we're done. Go ahead and refresh yourself. Then the only thing that this main window does is we just wait for the user to click the close button. So we're going to discard it so we actually keep the VI open. We are going to stop this loop, and then we're going to shut down the panel array manager because it does spawn a VI asynchronously that's running to manage the events for the scroll bar and adjusting which subpanel things are inserted into. When we do that, it's going to give us out an array of all of the panels that were still registered with it, and then we're going to go ahead and make sure those are shut down too. And that's all this is doing. So this is an architecture that uses my by reference implementation that I frequently do. So in each of my classes, the only thing that's in my class private data is a DVR that we create with a constructor function. And all of these constructor functions call the parent method as well to make sure that throughout the inheritance chain, everything initializes itself appropriately. But we're going to take some private data cluster, create a DVR out of it, and that's the only thing that goes into the class. And then anytime we branch that class wire, we can still access the data that's stored in that DVR. As well as this by reference architecture still supports inheritance and dynamic dispatch, as we've seen with this. Our base class, our concrete classes aren't doing very much, but they do need to make sure they implement a constructor just in case. And on these panels, so what we're doing here is we're utilizing that intermediate classes, so that PPL panel that has that ID property. We're going to pull that out and just throw that into our display. And we're going to do some stuff with our panel base class. Our panel base class provides some events for us to know when we should shut down. We're going to tell it that we are in fact running. And we call this after we've registered for the events to make sure we don't lose any events. Sometimes it can take a little bit for something to get initialized. The LabVIEW task, the LabVIEW execution scheduler may run things out of order or may take a while to get to something, especially when we're trying to launch VIs asynchronously. So we do have some handshaking present in this framework to make sure we don't miss any events. If we were told to, so right away, if this has an error trying to get anything going, it's not going to block. It's going to immediately shut this panel array down. So we want to make sure that the panels are in fact listening for events so we can get them all shut down properly. And then the only thing these are doing is closing when we need them to. Another option that is available is there's this visibility changed event that we can use. So actually let's take this on, let's do this in panel B where we're not doing much else yet. But let's go ahead and register for this event as well. And what this will do is every time this is put into a subpanel, it will let us know that we're visible. And so we've got this visible flag. This will be a true or false. Anytime we're taking it out of a subpanel, we'll get a false here. And so what we're going to do is we're going to start this off. Let me go ahead and get all this shifted down a little bit. We're going to create this. So I actually have a utility function available in the base class that's going to handle it, that's going to make it easy for us to change our event structure timeout whenever we get this event. So if we open up our base class, we've got a public function. Where did I put this? Did I get rid of this? Oh, it's protected. That's right, because we're only meant to use it within inherited panels. So visible, so we're going to pass that in, and then we're going to put a true. So we've got this update flag for whenever we actually have run this visibility changed event. and then we're going to tell it, anytime this is true, this sub-VI will pay attention to what the visible status is. If this is false, which is going to be the case, anytime we don't wire true into here, it'll ignore what this value is. But what this will let us do is basically we're going to start out with 0 timeout because this panel starts invisible. Then what will happen is as long as we stay invisible, our timeout, every time we get an event, let's say we were handling some other communication task with something else running in this application, we could stay at a no, not having a timeout. But let's say at some point this becomes visible and we want to make sure the user interface is keeping updated with something that's happening somewhere in the application. Let's say we're displaying some DAC readings. We want to keep those updated, but we only need to keep those updated while the panel is visible. So if especially if we're running a bunch of these, it would be nice to not always be running our display update code when we don't need to be. But so for this, we'll go ahead and demo what this might look like. So we're just going to keep track of the iteration count. So we'll see that we can bring it back into view. We'll see this start running. We can put it out of view. And when we bring it back into view, when we scroll back to that panel, we'll see that it is picking up where it left off, that it wasn't getting into this timeout case while it wasn't visible. So we'll go ahead, we'll save that, we'll run this. And now we see we've got these blue guys here that are all counting away. And they're gonna, updating their iteration count at approximately 10 Hertz. Now if I scroll down, we're gonna eventually find, look, this blue one is starting off from 0. This one wasn't running until we made it visible. Now there was a blue one that we just put out of view, so this one's still counting away. If we scroll back up, we should see that the one that's going to come back into view will be significantly less than this one. So it basically paused its updating while it was not displayed. And this works for any number of elements. And we can see, I can scroll through this pretty quickly. And the only overhead of adjusting the scroll position is pulling the elements out of the subpanels and reinserting the appropriate panels. All the while, their code is still running in the background. We've just now utilized that event to be able to change how much we're doing when we're not displayed. And we'll go ahead and stop it. Everything shuts down cleanly. I can close the project. We don't get any error, we don't get any notifications that stuff is still running in the background. But yeah, so that is something I plan to use a lot. Features something like that, a polymorphic array where each item can be a different concrete implementation would be really useful for things like recipe editors, where depending on the step type, you can change it to a new panel type. It'd be super useful for becoming the view from a model view controller design, where instead of passing in a string ID, you could actually pass in a class instance of the model data that they're meant to display data for, and then they would use accessors on that model class instance to update their front panels. But this is definitely something that I plan on using a lot in the future.